Have you ever really stopped to think about what happens when you click on a link? It feels instantaneous, right? But behind that one simple click is this incredible, massive system at work. Today, we're going to pull back that curtain and look at the core building blocks of the internet: hosts, IP addresses, and networks. Let's dive in.
So, let's start with a big question. How do the billions of devices we use every single day, I'm talking our phones, our laptops, even our smart refrigerators, how do they actually talk to each other from all corners of the globe? You know, it feels like magic, but I promise you it's not. It's actually just a few really simple, logical ideas working together perfectly.
To even begin to answer that question, we have to start from the ground up. We're going to look at the absolute, most fundamental pieces of the puzzle that make our entire digital world possible.
First things first, let's meet the main characters in this story. They're called hosts, and believe me, they are at the very heart of every single online interaction you have ever had.
So, what in the world is a host? Well, it's a simple idea, but it's incredibly powerful. A host is just any device on a network that can send or receive traffic. That's it. It's the starting point and the ending point for all digital communication. And this is where it starts to get really interesting. You see, a host isn't just your computer or your phone. Think bigger. It's your smart TV, it's your smartwatch, it's the massive cloud servers that power your favorite apps, and yes, it's even your smart refrigerator that tells you when you're out of milk. If it's connected and it's communicating, guess what? It's a host.
Now, these hosts, they typically play one of two main roles in any conversation. They're either a client or they're a server. The easiest way to think about it is like this. Your web browser acts as the client when it initiates a request, when it asks for a website. And the website's computer, which responds by sending that page back to you, that's the server. Simple, right? One asks, the other answers.
But, and this is a really important but, these labels aren't permanent tattoos. Client and server are just roles they play in one specific conversation. For instance, that website server might need to grab some information from a database. Well, in that little chat, the web server suddenly becomes the client, and the database acts as the server. It all just depends on who's doing the asking and who's doing the answering at that very moment.
Okay, so we've got our hosts, all these billions of connected devices. But how do they find each other in the vast, vast digital universe? Well, just like you need a street address to get a letter delivered, every single host needs its own digital address.
Honestly, the best analogy here is the good old-fashioned postal service. To send and receive mail, you need a very specific mailing address. It's the exact same idea for a host. For it to send and receive data on a network, it absolutely needs an IP address. It's that simple, and it's that crucial.
So what is an IP address, really? Think of it as the unique identity card for every single host on a network. Every little piece of data that gets sent out, every single packet is stamped with a from IP address and a to IP address. It's literally the digital version of the source and destination addresses on an envelope.
Now, these IP addresses aren't just random numbers pulled out of a hat. No, they're organized in this really clever, hierarchical way, kind of like a company's org chart. And this clever structure is the secret sauce that lets data get routed so efficiently across the entire globe. Let's walk through a quick example. So imagine a big company. We'll call it Acme Corporation. They might get assigned a whole range of addresses that all start with the number 10.
Now let's zoom in. Within Acme, maybe the London office gets a smaller, more specific slice of that range. Everything that starts with 10.30.
And we can get even more specific. The sales team inside that London office could get an even tighter range, 10.30.55. You see how that works? The address itself becomes a set of directions. This structure is what lets internet routers figure out the general direction to send data without needing a map of every single device on the entire planet. It's genius. So we have hosts, and they all have addresses. What's the final piece of the puzzle? Well, they need a place to actually communicate, the roads, if you will. And that's where the network comes in.
A network is really just a logical group of hosts connected in a way that allows traffic to travel between them. It is the highway system that lets all that data get from one address to another.
What's so cool about this idea is how beautifully it scales. You can start with two separate computers, right? They can't talk to each other. But you connect them with a cable, and boom, you've just created the world's smallest network. Then you can start connecting different networks to each other, and when you do that on a global scale, well, you get the internet. And that right there, that is the big aha moment. The internet, this unbelievably complex thing we use every second of the day, is really just a massive collection of these smaller interconnected networks. Your home Wi-Fi network is connected to your provider's network, which is connected to countless other networks all around the world. It really is a network of networks.
Okay, so let's do a quick recap. Let's put all these pieces together and see how these three simple, fundamental blocks create the digital world we all depend on.
So, here's what you really need to remember. Hosts are any and all devices that send or receive data. They can play the role of a client, who asks for stuff, or a server, who provides it. Every single one has a unique IP address. That's its digital mailing address. These hosts all connect to each other on a network. And finally, the internet is just the biggest network of them all, a giant network of all these other networks connected together.
So we've basically covered the what and the who of how the internet works, the hosts, their addresses, and the networks they live on. But that leaves us with a pretty fascinating question, doesn't it? How does the data actually make the trip across all those connections? Well, that's a story for another time.